Hello students, I trust you're doing well. I wanted to take a look at homework 3.2 for my course, and we're going to look at that front page, and we're going to talk about what would happen if I were reading resistance at the setting of R times 100 and R times 1K. So that's why we're going to consider those two settings, and we're going to be using this display again, and I'm just using this for demonstration purposes. We're reading the ohmic value, so where it says ohms at the very top, we're using these marks that are up at the very top, pointing up. As you can tell, this is a reverse scale, so all the way to the right is 0, all the way to the left is infinity. And this is a non-linear scale, so you can see that there's more marks between 0 and 1 than there are between 50 and 100. So it's a nonlinear scale, so let's take a look at what that would look like. Okay. This is our scale, and again, what I would do is I recommend is that we circle where we're reading. So we're going to read this scale at the very top. So those are my three positions, A, B, and C. And our first setting is going to be R times 100. And the way this works when you're reading ohmic values on this meter is I take the reading times the setting, and that's the value of my resistance. So we are reading some value between 15 and 20. There's 5 marks between 15 and 20, so each one of these marks is worth 1. So 15, 16, 17, 18, and 19. Some value between 18 and 19. So I'm going to call that 18.5 times 100, and that would be 1850 ohms. Now, as you see, as I go from A to B, is that my number's getting smaller. So this is 1850. If my scale is still set for R times 100, the value of B would be less. And so I'm looking at B, and I'm looking at some value that's between 6 and 8. And you see we have 4 marks between there, and each one of those marks is worth 0.5. So here's 6, 6.5, 7, 7.5, and 8. So I'm reading some value between 6.5 and 7. I would call this maybe 6.75. So 6.75 times 100 is 675 ohms. And let's look at this next position here. And I'm looking at C. And C is a value between 1 and 2. There's 10 marks between 1 and 2. So 1, 1.1, 1.2. There's 1.5, 1.6, 1.7. So I'm some value between 1.6 and 1.7. We're going to call that 1.65. So 1.65 times 100 is 165 ohms. So that's what it would look like if my setting was on R times 100. Now I'm going to change my meter to R times 1K. And look, our needle's at the same position. And we're going to take those same values. Remember, I read 18.5 here. So 18.5 times 1K is 18.5 K ohms. And in B, we read 6.75 times 1K is 6.75 K ohms. And at the last one, we read 1.65 times 1K is 1.65 K ohm. So if I use the same needle positions and my goes from 100 to 1,000 or 100 to 1K ohm, is that my value in the second readings are going to be 10 times higher. So hopefully you'll do this exercise. These are the answers I got. So take a look at that and see if you can duplicate those answers and go through the rest of the exercise. I look forward to seeing you in class, and I wish you well.